much too long to not fall in love, but much too short to keep waiting around. We run ourselves into the ground. Oh, I'm terrified to tell you. Ooh, but deep down I think you already know. If patience is a virtue,
Hello everybody, I hope everyone is doing great today. I will briefly read through chat because this stream is a very sad occasion. This is the last educational stream that I'll be doing before my hiatus. Though I have to admit that quite a few of the questions that I got for the last Ask the Anything have also been quite educational, so maybe last educational stream is a bit of an overstatement. But it is the last Astrobite stream, which is really sad because, as you all know, the Astrobite streams are my favorite streams. So it really does feel like a goodbye. Oh, my intro was so loud. Oh, I was just saying that there were no technical difficulties for today, but I hope you guys can all hear me well. Hello, Shulian Dreams. Good morpher evening. Hello, Interstellar Alien. Last the stream until the observable universe resets itself. Well, hopefully not, because I would hope that the observable universe would continue. I've got a lot of questions from especially new chatters about like why I'm going on hiatus, and if you are curious, you just have to click the hiatus thing here. It leads you to the video where I talk about why I'm going on hiatus. And the reason for that is because I am entering a pretty major personal project of mine that I'm very excited to be working on. And so I hope the observable universe does not reset itself, because that also means that the project will be gone, which would not be very pleasant. Hello, Calcium. Hello, PogChamp. Hello, HumByV. Hello, Eggy. I can't believe Z is entering Metamorphosis. Well, I will come back as a beautiful butterfly. Hopefully I already am partially a beautiful butterfly though. Hello Hug Your Dogs. Hello Zilla. Hello Dwammer. Hello Astral. Sadly cannot stay. No worries. Thank you so much for singing by. Hello PR Camino. Hello Arky. Hello Stella. Yes. Hello Data. Foxy. Z is the load-bearing banana of the observable universe. That would be hilarious. Well, this stream is also very special because it turns out that there are actually 3 streams happening in Vtuber today. So Vtuber is the group that I'm part of. We're an indie group of scientific communicators. After my stream, we'll be raiding into Phi the Neutrophil stream, where he will be celebrating 100,000 subscribers on YouTube, which is a huge milestone. So we're gonna go and congratulate him. This is super exciting because Phi recently switched to being a full-time content creator. And so this is a very important milestone for his channel. And then after that, Mylan and Flatulence Incarnate, who was one of the major donors of the Diabetes Donathon a few months ago, are collaborating, and they're talking about... What are they talking about, actually? Let me pull this up because I don't want to spread this information. I literally just saw it. Yes, they're talking about accessible ABA interventions for children with visual impairments. If I recall correctly, yes, Flatulence Incarnate is an applied behavioral analyst. So that'll be super cool. So a lot of great educational streams today. Yes. But before we get started with this epic stream, I did want to give a quick announcement. So my last stream, guys, this is so sad. My last stream before my hiatus is going to be on Monday, August 10th at probably, I think 100%, 8 p.m. Central European Summertime. Oh, this is such a bittersweet announcement. I also know that in my hiatus video, I said the final stream would be like August 13th, but because of some unforeseen circumstances, such as a literal solar eclipse happening in Germany, I am doing my last stream a little bit more earlier than planned, so I hope that's alright with you guys. For this last stream, we will be answering questions from you all, and there are like 50 or 60 questions. There's going to be a lot of them, while driving a virtual bus, emphasis on virtual. We'll be talking about common questions about, you know, my channel, answering some questions about astrophysics, and of course sharing some last photos and celebrations together for our final stream. So it is very bittersweet, but I'm very excited to, be answering your questions. I don't know if I'll be able to watch last stream. Well, no worries. Yeah, hopefully no crying. No crying. No crying is allowed, but I think I will cry, guys. I'm already like watering up talking about it. Enjoy the eclipse. Yes, I'm so excited. It is only a partial eclipse in Germany, and I have a few friends who are going down to Spain to see it. But I think I will just be seeing the partial, but it will be a pretty large chunk of the sun, so that'll be super exciting. And if you're in Europe, please check it out. And if you can see totality, I really recommend it. It really is life-changing. Nobody could have predicted a solar eclipse. I mean, to be fair, we have a pretty good grasp on eclipses nowadays to be able to track them and understand when and where exactly they'll be happening. So, yeah. No crying allowed, but you're gonna cry anyway. Z is a rebel. Maybe I am. But I think rebels are supposed to be, like, tough-hearted and cool. I don't think I'd be very cool if I cry in this instance. I don't have the eclipse map, but if you just Google, there are various maps offered by, like, space.com, etc. I got to see totality once. It really is amazing. Yeah, I got to see totality as well in the United States. That was actually life-changing. It was really great. I can understand why people chase eclipses after that. Yes, I hope everyone who can see it can enjoy the eclipse. Have a nice stream. Well, thank you so Nona for visiting very briefly. It's hard to cry at hard. It's tough to cry at hard things. Yeah, exactly. But we've had so much fun these past few months, and frankly, I feel like we really made the most out of our streams together, and including this one, and the last stream as well. So we still have 2 streams left, counting this one. So let's make the most of them. I am so excited to be talking about this topic, guys. Because this is probably one of my favorite topics. We're going to be talking about dead galaxies today, which is super cool. Let me move chat out of the way. And we can get started on our articles. I'm just resizing things, sorry. I hope you guys have been staying cool, though. Last time I was talking about the heat wave, well, it's been coming back and forth again, but I'm leaving Germany, actually, in a few days, alongside my final stream. So I will be soon escaping the heat wave, which is the good news. And then I will be on vacation for a bit. So for the Orbeez members, stay tuned for some pretty epic images of where I'll be traveling. But frankly, I'm pretty excited to be leaving to also leave the heat. I've been getting these like heat rashes that have just been flaring up every time it gets hot. So yeah, even today I had to go get ice cream to like try to cool down, and I got 2 kugels. Kugels are scoops. I got 2 scoops instead of 1, and it was just so big, and it was dark chocolate ice cream. It was really bitter, but like really great. But it helped me cool down. So if you are in Europe, please stay safe. Please stay cool. A lot of my friends have been getting like similar heat rashes or eczema. So like, if you can, please get lotion, stay hydrated, etc. Yeah. Hello, Hywalian. I literally added 2 more AC units to my house in Florida. See, the thing that sucks about Europe is that there is no AC, especially in some of the older buildings in Germany. I think the worst experience that I've had here was that I was giving a talk at a university, and you know, most of these places like the libraries and the public spaces have AC design in them, but the room that I was giving my talk in was literally a greenhouse. And so as I was progressing through the talk, oh my god, thank you so much Data Foxy for becoming a member. I should gift memberships at my last stream, that is true. Sorry, what was I saying? Yes, so I was giving a talk, and as the talk progressed, the room was just getting hotter and hotter because there were people in the room. And I also overheat a little bit when I give a talk, right? And by the end, I was just like covered in sweat. I was disgusting. And I was getting all these great questions, but because I was overheating, like my computer, I was literally overheating, I felt like I wasn't able to articulate very well. So I'm hoping that as I head out of Germany, I'll be able to think a little bit better out of the heat. Always enjoyed lurking. I'll miss these streams. Oh, thank you so much, Toto. Thank you so much for stopping by. Hello, Jedi. 2 scoops of ice cream instead of 1 with the 3 euros you had from last year. Oh my god. Oh my god. I did mention this. Yeah, okay, so plot twist. I have a 5 euro bill. That's basically all I have. But anyways, I'm heading out in a week or so it doesn't really matter. But I went out for ice cream, right? And I also went to a restaurant and they were like, cash only. And so I was like freaking out. I was like, I don't know if I can pay this. Like, I don't have any cash. Like, all I have is like US dollars, which is like definitely not gonna work here. But fortunately, I was with my friend who is like a walking ATM, and she was able to pay for me, and I was able to Venmo her, and like that's what we've been doing this whole time. Like if they're cash only, I just like my friend pays for me, and then I just Venmo her back. So it's great. But so moral of the story is to definitely get enough cash if you are in Germany. They also don't take American Express in a lot of places too. That's another thing. The heat is no joke these days. Yeah, it's been brutal. My health has not been very good actually. These heat rashes are one issue. My sleep quality has declined. It's definitely been really tough health-wise. But I would have to say I love Germany. I would just love to come back when it's less hot. Hello, Poison! Thank you so much for stopping by! Oh my god. I was just mentioning that we're going to have 3 back-to-back streams for Vtuber today. Because we're going to raid into 5s, a 100k celebration, and then we have Mylan's stream after that. Do you live in Germany or are you just visiting? Well, I am living in Germany at the moment. But as I've talked about in my previous streams, I am usually in the Pacific time zone in the United States. So this is just a temporary situation. But yeah, I would love to come back, and actually it is partially in my plans that I will be returning back to Germany. I don't know if I will be streaming by that time of that return. But we'll see. We'll see. The Vtuber chain, indeed. Yes, indeed. Alright, that's enough yapping for now. I wonder if I can just... I don't know if this is... I feel like I want to include this thumbnail to keep people informed, but it makes me very sad, so I think I might hide it. Alright, we can read our first article. So today's theme is about dead galaxies. So let me just quickly pin... Oh, I will just send the article. If you are on the Twitch, it will be in the YouTube description. I just saw a message here. I hope you return with the automaton so the people in Germany can learn the instrument. I wish I brought the automaton, but I brought very little things because of how temporary my Germany stay is. Another thing is that as part of the 10,000 Orbeez milestone, I was going to do a violin concert. That is something that I plan on doing upon my return, so I'll keep you guys updated. Alright, observing the end of star formation in galaxies. I came across this article quite a while ago, but I wanted to share it. For those of you who are new here, Astrobites, they basically translate articles into lay-friendly summaries. And so it's a really great way if you want to get started with reading with the literature, getting familiar with astrophysical terminology in a very friendly format. So yeah. So the first link here leads to the original scientific article, but we will just be reading the Astrobite for today. Alright. How and why do galaxies stop forming stars? Galaxies serve as important laboratories for many subfields of astrophysics. As such, astrophysics are interested in the galactic life cycle, from how galaxies are born to the end of their formation. Oh, as such, comma, astrophysicists are interested in the full galactic life cycle, yes. Whereas young galaxies in the distant universe are actively forming stars, many nearby galaxies are much quieter, with little or no ongoing star formation. Astronomers like to describe these galaxies as red and dead, because their stars are older and therefore appear redder in color. I think I've actually met one of the people who like originated with this term or like brought this into popularity. It's a very funny term because it rhymes. The process by which galaxies shut down their star formation is known as quenching, and it causes galaxies to become quiescent. So those two are synonyms. Understanding the origin of quiescent galaxies is a fundamental question in galaxy evolution. Studying this process is challenging, however, because star formations intertwine with many other factors that shape galaxies, including their environments and supermassive black holes. Galaxies are so dynamic, and that is so cool. Star formation really is tied with so many different processes that it's so difficult to understand. So in this work, they're looking at this golden sample of galaxies on the right. These are gorgeous, by the way. I love these spiral galaxies, and these are what, redshift 0.27? These galaxies were chosen because of their clear detection and range from edge-on, so like this one, to face-on views, as well as shapes. The authors divided each galaxy into small, resolved regions in which they measured the star formation. I also love how well these visuals work. Like, the author of this article really took the time to combine both Figure 1 and Figure 5 in the paper together. These galaxies all look so different. Like, this one looks kind of more like a hurricane. This one, like, looks like it's kind of clumpy and breaking apart. I mean, this one's just on its edge. This one has this really bright off-center point here. Super cool. Star formation occurs on scales that are much smaller and over time scales much shorter than the global properties and overall lifetime of the galaxy. By observing star formation on these smaller scales over time, astronomers can gain a clearer picture of how star formation seasons in the galaxy and determine whether this process is driven from the inside out, starting with a supermassive black hole in the galaxy's center, or from outside in, influenced by environmental effects. What makes them look different? Well, it's a variety of different processes. Some of these galaxies might be interacting, some of them might be star forming, some of them might have just undergone an interaction with another galaxy. There are so many reasons why galaxies can look different, which is why galaxy shape is so important, because by looking at the galaxy shape, we can then trace back its history, such as when it last interacted or when it last formed stars. Hello, Ruler. The visuals remind me so much of Kurtisov's artistic style. I think it's the color scheme, like this Viridis color scheme. Yes. Yeah, so they also discuss it here about whether star formation is driven from the inside out or from the outside in, influenced by environmental effects. That affects star formation, and we can visually see star formation and understand its tracers. But yeah, let's see. In today's paper, the authors used the Cosmic Assembly Near-Infrared Deep Extragalactic Legacy Survey, or CANDLES. I love astrophysical acronyms, by the way. People are so creative when it comes to acronyms. It's great. It's great. I love it. It's amazing. I also know that, like, I mentioned this on a previous stream, but there's a research group that looks at galaxies, and it's called, like, the BOBA group. And, like, each of the letters of boba, like, stands for a different character, and, like, their, like, logo, I think, is, like, a cat sipping boba. This is at UMass Amherst. It's great. I love how creative astrophysicists are with acronyms. It's so fun. So they're using ultraviolet wavelengths to examine the 9 golden galaxies. They then reconstruct the star formation histories within small regions of each galaxy to detect the earliest signs of quenching. So, when stars die. Alright, so let's understand how star formation histories work. Oh, this is perfect, because I was actually originally going to give a live lecture on this topic, but unfortunately I ran out of time. That's something I can do after my hiatus. To trace a galaxy's star formation over cosmic time, today's authors model its integrated light, which encodes the many episodes of past star formation using spectral energy distribution, or SED fitting. By comparing a galaxy's light across many wavelengths to computer models, SED fitting can estimate the ages of its stars and when they formed. This approach allows astronomers to study how a galaxy's star formation rate evolves as a function of its stellar mass, known as the star formation rate stellar mass relation. I think another way to explain SDD fitting, because it is such an important tool, is that astronomers, just by looking at the galaxy's light, can determine the entire history of the galaxy. Which is insane to me, because you think at one snapshot you can only look at the galaxy at the present moment, which is true, but from that light you can also deduce the population of young stars, the population of old stars, and by tracing those back together, you can determine the entire history of the galaxy, which is really cool. Note that since the paper considers the star formation rate and the stellar mass in individual regions of the galaxy, it analyzes these properties as surface densities instead of the total value. Okay. Using SDD fitting, the authors determined the expected star formation rate and stellar mass of the regions from 250 million years to 1 billion years before the time of observation. Figure 2 shows the line of best fit for the star formation rate and stellar mass relation of the regions for each galaxy, before and at the time of observation. 1 billion years before the observations, the star formation rate stellar mass relations are very similar across the sample. However, by the time of observations, so this right panel, the overall star formation rates have decreased slightly. Okay, so it goes down this way, indicating that the galaxies are beginning to quench. They also exhibit increased variation, suggesting that each galaxy is quenching in a different way. So I guess if we look at this plot, so this is 1 gigayear, so 1 billion years look back time. What that means is that we're looking 1 billion years back at time compared to the time of observation. So the best fit, star formation rate and stellar mass relation for the regions of each galaxy. So we have 1 billion years before and then at the time of observation. So it looks like the galaxies appear to have the same relation, but their variation at the time of observation suggests that the galaxies have begun quenching or dying, I guess, in different ways. So they've stopped star formation, which is why it's starting to sink a little bit here and the lines are beginning to diverge. To further probe how these galaxies are starting to quench, the authors measure the specific star formation rate of the regions as a function of their distance from the center of the galaxy. The specific star formation rate can be thought of as the rate of new star formation relative to the amount of existing stellar mass. Oh shoot, my computer apparently is overheating. I'm gonna remove this cover that I put below it. Hopefully that helps with circulation. My computer is really on its last legs, guys. Okay, yes. Yes, the specific star formation rate can be thought of as the rate of new star formation relative to the amount of existing stellar mass. It's hot there, yeah, no, it's also the heat. I'm also sweating a lot right now. And the laptop is also very hot. Oh my god, hello, Fi! Pray for laptop kun. Well, when I go back to the US, I think I'll have to get it repaired because my keys have stopped working, I think as a result of the heat. Because the keys that have stopped working are coincidentally the keys that are on top of my battery. So I think it is causing damage. Yeah, my Mac is not doing very well. That is true. I guess also the heat of where I'm at right now too. Hello, Block Boy. Who will overheat for Zio or laptop? I think both are overheating right now, actually. I literally have my hair up and like I'm still overheating. What's really funny is that it was so hot the other day that I was out with my friend and she has really long hair. And it was so hot that at one point we literally had to go to the pharmacy and buy her a hair clip. Like, just on a whim. Cannot imagine how bad it is in Germany right now. Yeah, I mean, it's been over 100 degrees. So it's been pretty bad. RIP battery. I don't know if it melted the sensors, but sadly enough, this overheating issue is the same reason why I had to get my laptop basically entirely replaced last time. Because of the Mac, you can't replace like a singular key or just the keyboard. You have to replace the entire bottom of the laptop, which includes like the CPU and everything. So, yeah, RIP. Hope you have a separate keyboard. Actually, I do. I brought my separate keyboard for the weekend. I don't know if you guys can hear that, but yeah, it's right there. One more month before summer ends. Well, I will be out of Germany in less than a week now, so a little less than a month, thank God, because my rashes have been getting worse as well. I wonder if the battery's physically swelling. I don't think so. At least I don't see anything. I've replaced multiple laptop keyboards and screens. Yeah, I was watching Marquez Brownlee, and I think he was talking about a computer where you can like individually replace the parts, and I was like, gosh, I think I might go for that. 34C, holy smokes. Please stay warm. Not warm, please stay cool. Yeah. I've really been trying my best to stay cool for sure. Alright, let's keep on reading. Yeah, so let's look at figure 3. Shows 3 examples of the galaxies studying this work. Once again, the star formation rate of the regions decreased over the course of 1 billion years. However, the regions where the star formation rate has declined the most rapidly differ from galaxy to galaxy. That's really interesting because they actually have these images here, so they can spatially determine where the star formation regions are. Ranging from the central regions to the mid-disk to the outskirts, as each galaxy is undergoing a different quenching mechanism. So basically there are many ways that galaxies can die. So let's see what's going on here. The specific star formation rate as a function of radial distance. So this is the center of the galaxy. And it looks like we follow this blue line at the time of observation. It decreases roughly at 9 kiloparsecs out from the galaxy. But in this instance, the star formation rate is increasing on the outskirts of the galaxy. And in this instance, it's kind of going down and then up again. That's super interesting. 34C is normal for me? What? That brain is called framework. Yes, thank you, Dwarmer. However, the regions where the star formation decreases most significantly, indicated by the yellow boxes, varies. So this one's kind of more middle outskirts, this was more central, and then this is definitely outskirts. Detecting the earliest signs of quenching. It should be noted that all the galaxies in this study are still star forming. However, they are on the verge of having their star formation suppressed, offering valuable insight into how quenching begins and how diverse the process can be. New telescopes are pushing the boundaries of what we can observe. On one hand, the James Webb Space Telescope can capture galaxies at exceptionally high resolution. On the other hand, the Vera C. Rubin Observatory and the Nancy Graves Roman Observatory will deliver vast datasets containing billions of galaxies. Future investigations leveraging these facilities could reveal more about the physical processes that quench galaxies on small scales, shedding light on the mechanisms that drive galaxy evolution. This is super cool, guys. It's super interesting to see how the star forming regions vary. Hello, what is happening? We are reading about how galaxies die. And looks like we just finished this article that talked about these 9 different star-forming galaxies in this survey called Candles. It's a Hubble survey. And they looked at specific regions where galaxies have stopped star-forming. What's really interesting is that these galaxies as a whole are star-forming together. But if you look spatially, they may or may not be star-forming. Are you an astronomer? Yes, I'm an IRL astrophysicist. Hello, Germanium! Rubin Observatory mentioned. Yes, Rubin is so cool. Actually, I just sent an article. So, if you're a member that is Red Supergiant tier or higher, I send out a roughly weekly, it's more like roughly every 2 weeks, newsletter following one of my, giving updates from my IRL research and where I've been traveling to. And I also give a quick summary of my favorite paper that week. And I'll mention this right now. The paper that I shared last week was actually a discovery by the Rubin Observatory. It was the first satellite galaxy in the Milky Way that was found with the Rubin Observatory. And it's very, very tiny, which is super cool. It's cool when you remember that this information from the past, due to the speed of light. Yeah, I mean, they are comparing galaxies 1 billion years ago to the time of observation. You really get to be a time traveler when you're an astrophysicist. Super cool. Well, thank you, Shalini, after studying Fulbright Fellowship. Really cool. Yeah, great article. I love the visuals on this. She did a really great job with this. I love how she, like, this is actually from figure 1 and figure 5 together, which is super cool. Woohoo! So we just went through our first article. That was really cool, guys. Let me take a sip of beverage. Whew. You know what would hit so hard right now? Is definitely freshly squeezed lemonade. I've been craving this whole week to help with the heat. Woohoo! So the next article we're gonna read, I will send it here. Oh, I got a message from chat. This is my first stream. Oh, well, thank you so much, PR, for joining. But it sounds like you're dying next week. Well, I'm not dying. I'm just going on an indefinite hiatus of several months, to up to a year. Will you keep up the articles while you're gone? Well, I will be streaming, but if you are a YouTube member, I do send my newsletter highlighting my favorite article from that week. So if you are curious to read up on that, I would recommend joining membership, but of course, no pressure. That is only on YouTube, by the way. I do not have Twitch donations or subs, or I'm not sure what exactly the terminology is enabled, so yeah. Woohoo! Next article. We're zooming today, guys. I actually did not think we'd read that article that quickly. We really went fast on that one. This next article, I love the title. UFO sighting in a dead galaxy. I feel like I can give Astrobites a little bit of credit, even though I don't typically like when articles have like the word UFO or aliens or something to be kind of clickbaity. But in this case, the UFO actually refers to the name of the galaxy, the name of the event, ultra-fast outflows that are actually called UFOs. So I will let this UFO slide. The upselling her membership when she's about to go on hiatus. Well, on my hiatus video, I do say that please do not feel obligated to support me while I'm gone. The membership has been helpful and the donations have definitely been helpful. But of course, it is extra credit. Just think of it like extra credit at your school. Some actually clever clickbait for once. Yeah, that's why I'm saying, like, I feel like I don't really like it when people are like, UFO this, UFO that. But in this case, it actually works because the UFOs in this case don't refer to aliens. They refer to ultra-fast outflows, which we'll read about in just a second. It reminds me of when the pulsars were called little green men. Yeah, that is true. That is true. Well, when we first discovered pulsars, I mean, they were so mysterious and we didn't understand the physical reason as to why they, like, where they came from and what the signal was from. And so thinking it was aliens was pretty reasonable at the time. I mean, if you see a repeating high energy signal seemingly coming out of nowhere, it could be attributed to aliens. But as we found out later on, we gave a physical reasoning to pulsars, which is that they're rotating neutron stars. And that's why they pulse in equal intervals. So yeah. So let's read about our UFO sighting. First detection of ultra-fast outflows in a quiescent galaxy. So we just learned that quiescent means quenched, which means that it's no longer forming stars. So let's read this. Galaxies are windy places. At the center of some galaxies lies a supermassive black hole, accreting or gaining the gas and dust around it, called an active galactic nucleus, or AGN. AGN are very energetic environments, generating winds and jets that can launch material at thousands of kilometers per second out of their host galaxy. The anatomy of an AGN with its high energy output is shown in Figure 1. This is so cool, guys. Shout out NASA, ESA, and Leia Hustak for this epic image. These winds won't just give you a bad hair day. They can regulate the growth of the entire galaxy by either pushing out interstellar gas and limiting star formation, or by compressing interstellar gas and enhancing star formation. And I guess there are other Astrobites on AGN winds if you want to read more. So AGNs refer to the supermassive black holes at the center of these galaxies. Sorry, the song command doesn't work, but this is the Summertide album by Aloha. Here, I can send it. So the most powerful AGN winds are called ultrafast outflows, or UFOs. Previously, UFOs have only been detected in gas-rich star-forming galaxies. In today's paper, the authors report the first ever discovery of a UFO in a quiescent galaxy, an old galaxy that is no longer forming stars. That is super interesting because that means that it's actively producing these winds and gas out of the galaxy, even though the galaxy itself is not forming stars. The role of AGN winds in quiescent galaxies is not well understood, so this discovery can help reveal how black holes keep galaxies quenched. But first, how do we spot a UFO? Hello Kami, thank you so much for stopping by. I can't join today, then have a wonderful stream. Well, thank you so much for stopping by briefly. This is my second to last stream. My last stream will be on Monday, so I hope you'll be there. So let's see how to spot a UFO. This article is so fun. I love when the Astrobite authors have fun with their articles. It's a galaxy, it's an AGN, it's a UFO. Astronomers believe that UFOs are launched from the accretion disk of infalling gas that surrounds the AGN. This disk produces a bright, continuous spectra of X-rays. So the first step is to observe an AGN with an X-ray telescope, or in this case, two. The AGN in today's spike, KUG1208386. Astrophysicists can think of good acronyms, but the names can be kind of tough. Was observed by the X-ray satellites XMM Newton and NuSTAR. Together, 5 spectra were collected and jointly analyzed. 2 super cool X-ray satellites, by the way. Next, develop a model of what a normal AGN X-ray spectrum looks like. So, we're taking a look at the light of a normal supermassive black hole. The model should consider the amount of X-ray photons emitted in the accretion disk, as well as the effects of gas and dust in the galaxy that can absorb or reflect these photons. All that's left to do is to subtract your observed spectra from your model spectra to get the residuals. If you see any spikes or dips in your residual, then you just might have found some emission or absorption lines. The authors of today's spike found an iron emission line, as well as a strong absorption feature at 7.25 kilo electron volts. However, the highest energy expected of an AGN absorption feature is only 7.11 to 7.13 kilo electron volts. So what's going on in the spectrum? The authors concluded that the observing gas is moving towards us with an enormous speed, causing the line to be blue shifted to higher energy from the Doppler effect. That's the same effect that causes ambient sounds to change as it approaches and departs from you. The size of the blue shift tells us that this must be an ultra-fast outflow, racing towards us at more than 4% of the speed of light. That's a whopping 12,000 kilometers per second. Yeah, that's incredible. I appreciate when scientists are also good writers. They don't just vomit jargon, but actually try to capture the reader's attention. Yeah, I totally agree with that. I think also recently, in the age of doom scrolling and Instagram, it is really hard to get people's attention. Some people kind of navigate that by using clickbait articles or by having like slight misinformation in the title, which I strongly disagree with. But some people can get really creative, and I think that's really where scientific communicators can shine, which is that they think of really creative titles, really creative ways to continue to re-grasp the reader's attention as they continue to read. Fire says, sharing is the best part of science. That is very true. I completely agree with that. Sharing is one of the coolest parts of science too. I think honestly, science, I talked about this earlier. I've been having philosophical discussions with some people about, like, why do we do science? And science is really based off of trust. And that trust comes from talking with other people, sharing our work, and also being asked questions, having your work really be interrogated to the furthest extent. And that isn't a bad thing, in fact. Having your work interrogated sounds kind of scary, and in some cases it can be. But in other cases, it also means that you're going through the scientific process. You're able to make sure that your science is robust by having other eyes on it. It's the job of science communicators to bridge the gap between academia and the average person. Yeah, I think especially now more than ever, where there's been a lot of decreased trust in science, being a good scientific communicator is really important. I mean, after all, that's kind of why I got into this whole VTubing thing in the first place, right? I thought it'd be really cool to talk about science, and also, I can never shut up about astrophysics. Like, guys, you guys have no idea. Like, during my day, like, you know, I'm doing my research during the day, I'm meeting with people during the day to talk about astrophysics, and then I'm streaming in the evening to talk about astrophysics. So my whole day is astrophysics, and I love it so much, and it's really great. And if I were to share even an ounce of that passion to somebody else and get them into astrophysics, that would just mean that my job is complete. Of course, like, there are various ways that people can be inspired by scientific communicators. Like, you know, they could actually go into science, or they could be like, wow, this is super cool, and go down a Wikipedia rabbit hole. But I think even the smallest difference is pretty big, especially nowadays. Sorry, that was that was a bit of a tangent, but I just wanted to talk about that because it's honestly the reason why I started this channel. It's a bird, it's a plane, no, it's gas at 12,000 kilometers per second. Yeah, at 4% the speed of light. I meet someone, I info dump on astrophysics, we become friends. That is so true. I feel the so far I cannot shut up about certain topics either. Wait, guys, earlier today, I was like talking with my friends about my love for cuneiform, which is like another thing that I've been recently going down a rabbit hole on. Recent is probably an understatement. This has been going on for several months. I'm very obsessed with cuneiform. But anywho, I just love when people talk about something and they get so excited that you can see like the sparkle in their eyes. And this can be for anything. I've seen this when people talk about finance. I've seen this when people talk about sports. I've seen this when people talk about music, and of course also in astrophysics. And it really comes to show how different people are, and really, like, what better way to like celebrate our lives than to like truly enjoy what we're studying and learning about. I feel like that's what inherently makes us human. Sorry for the philosophical discussion. Okay, back on task. Back on task. I think passion is one of the greatest human experiences. I agree with that. I mean, there's just been so much art and work done on passion. Love is the antidote to nihilism. I agree with that. I recently read this book. I really recommend it. It's called Tuesdays with Maury. It's quite an old book, actually. I like recommended it to my mom, and she's like, "Yeah, I already read this," and I was like, "Oh, okay." Basically, it's a story of this guy as he meets with his mentor, Maury, every Tuesday. Maury was diagnosed with Lou Gehrig's disease and is slowly deteriorating, and I guess, I mean, it's pretty obvious that by the end he does die, but in between he does share tidbits of his experiences and some of his life's greatest lessons as he's basically approaching death in a very close like immediacy. And he was saying that the purpose of human life should just be devote yourself to love, devote yourself to community. And at the end of the day, love is really the thing that will carry you past your life. It is sort of the impact that you make on other people. It's a really great book. I really recommend it. It's called Tuesdays with Maury. It's a wonderful thing for people to be passionate about. Cuneiform. Yes. So this started like a few months ago. I started reading up on cuneiform, and then I did a stream where I read about cuneiform, and I learned so many cool things. And then we actually wrote cuneiform, and then somebody gifted me on Throne the cuneiform book, and I read it so much that like the spine started to shatter, and like it's one of my favorite books ever. I'm really mesmerized by it. It's really cool. They use like a base 60 system. The history was so long that like there were historians in late Mesopotamia studying early Mesopotamian cuneiform. It's a really cool language. Yeah, sorry for the... Well, I don't think I should apologize for my passing in cuneiform, but we did get slightly off task. We were reading about ultra-fast outflows, or UFOs, and I guess what they're talking about here is that they found that the lines were, the spectral lines, so the light, was blue shifted, which implies that the UFO is approaching towards us, and they found out that it's approaching at 4% the speed of light, which is incredible. I want to do a monster script reading someday. That's super cool. I would love to see that. Oh, okay, so let's read the caption. The fluxus is the energy of the collected X-ray spectra. The observations are labeled PN and MOS1 and are shown with the blue and the red dots. The spectrum from New Star is labeled FTMA and plotted as the orange dots. The authors tried 3 different models to fit the data. The iron emission line and the UFO. Wow, so that's right here. This dip in the dip right here. The dip and flux are labeled. Thanks for the recommendation. I'm gonna check it out. Guys, I've been reading so much. In fact, I've already read 65 books this year. I just read whenever I get the chance. On trains, on buses, in between meetings. I have like a PDF book. I go one nonfiction, one fiction at a time. Reading is really great, and I've been getting more into it, which has been amazing. Alright, now that we have a UFO in our sights, it's time to zoom out and take a look at the host galaxy. The authors use spectra from the DESI survey and multi-wavelength image data to fit the spectral energy distribution of the galaxy and estimate its star formation rate. They find an exceptionally low star formation rate, indicating that this massive quiescent galaxy that stopped forming new stars around 9 billion years ago. That's insane because the universe is 13.8 billion years old. So it's been dead for a really long time. But it's still producing this incredible outflow, which is very strange. While UFOs are very time variable, energetic UFOs like the one detected in KUG 1208 have enough energy to affect the evolution of the host galaxy. So what effect can a UFO have on an already dead galaxy? I lose count of how much I read. I've been using Goodreads. I've been using Goodreads for many years, actually. I think I have over 700 books logged in my Goodreads, actually. It's great. Hello, Wombologist. So let's look at how ultra-fast outflows can kill galaxies. Quiescent, or dead galaxies, have recently become a hot topic thanks to the James Webb Space Telescope. JWST has discovered massive dead galaxies, or quiescent galaxies, much earlier in the universe's history than astronomers previously thought were possible. It's not only surprising that star formation shut off so early in these galaxies, but that it has stayed off ever since. Over time, the gas in the galactic halo can cool, condense, and eventually reignite star formation. In order for these galaxies to stay quiescent over billions of years, there must be some mechanism continuously heating the gas. The authors of today's Byte propose that in KUG 1208, the central AGN, or the supermassive black hole, may provide this heating through its outflows. As the winds plow through the surrounding gas, it injects energy and stirs up large-scale turbulence that prevents the gas from cooling and condensing. This process would explain the presence of the UFO and how this galaxy has remained quiescent for such a long time. So it seems like that ultra-fast outflow has basically killed the galaxy, preventing it from forming new stars because it kind of mixes up the gas and heats it up. In order for stars to form, there needs to A, be enough gas, and B, that gas has to have good conditions. And those good conditions means that it has to be low enough temperature, it also has to have enough pressure for stars to form. And when that isn't the case, stars can't form and the galaxy remains quiescent or dead. So that's super interesting. Additional observations of AGN winds and quiescent galaxies are needed to confirm this theory, but the UFO detection offers an exciting new clue for understanding massive quiescent galaxies in both the early universe and our own galactic neighborhood. Well, thank you so much, Madison Van Wingarden, who studies galactic formation and evolution of the distant universe. Super cool. How UFOs can kill galaxies sounds like a subplot from Guardians of the Galaxy. I think this is a testament to how good astronomers, astrophysicists are at naming things. I think UFOs bit of a mixed bag because it can be confused with like unidentified, UFO like as in aliens. But in this instance, I think it's pretty creative. So yeah, that was a pretty fun read, guys. We're really zooming through these articles. Let me pull up the next. This was the third or last one, but if we have time, we can read one more. The last one that I have on the list is actually not about dead galaxies. It's about how do spiral galaxies form, which I thought would be really cool to share because this is a question that I've gotten quite a few times. And the last one that I have on the list is kind of more like a scientific review than it is of an actual scientific article. So yeah. Whew, I'm gonna drink some water and carefully remove my microphone, aka my phone, off of my water bottle for this. Maybe sorry, I'm just trying to reset my mic again. Oh. Maybe with some extra time we can yap for a bit. Or maybe we can play a bit of Zelda Singularity because I actually haven't checked the game in a bit because I've been busy. But I've made quite a bit of progress. Like I unlocked the dinosaurs. Maybe that might be cool. But we are planning to raid into 5's 100,000 subscribers stream at roughly 7:30. Oh, thank you so much, Stella, for stopping by. Hopefully I can stop by your last stream. Well, I hope you can too. I hope you can too. Alright. Next article. Speeding under pressure on the intergalactic highway. What is this Cars themed article? UFOs because I matter we don't know about yet. I don't know if it went over that in the article I just joined. Well, we've detected... Oh, my phone almost fell off. We've detected UFOs with baryonic matter, which is matter that we can see and observe. I think you might be asking if we can observe UFOs with dark matter, for instance. I think that is not possible because dark matter doesn't interact with the electromagnetic force. And so dark matter exists throughout a galaxy halo and it's basically everywhere, but it wouldn't be like ejected out in an outflow, for instance. It's not affected by the same processes of matter that affects baryonic matter, or the matter that we can see and touch. But what may be really interesting for you is that galaxies are actually formed at the center of dark matter overdensities. In other words, there are these dark matter spheres that exist in our universe, and at the center, that's where the galaxies form. And so dark matter is a very important part of understanding how galaxies form. In fact, there are some cosmological simulations, or simulations of galaxies, that only use dark matter. And can help us trace the structure of galaxies in our universe. Because we can sort of see like a bigger web of galaxies formed by the dark matter. So, yeah. Hopefully that helps answer your question. Alright, next article. Let's look at this 100 kiloparsec ram pressure tail trailing the group galaxy. The pressures of outer space. Space is never truly a vacuum, and the same is true for the space between galaxies. Galaxies are usually a part of groups or clusters, the former being more sparse, and the latter being a more dense collection of gravitationally associated and perhaps also dynamically bound galaxies. The intergalactic medium pervades the space between galaxies within groups and clusters. This medium consists of ionized plasma, which has been ejected or removed from galaxies due to various physical processes. The medium is more dense in clusters than in groups. As galaxies move through this medium, if the medium is dense enough, or if the velocity of the galaxy is high enough, or in most cases a combination of both, the medium can exert pressure on the gas inside the galaxy and remove it off of the main body. This process is called ram pressure stripping. As galaxies lose gas, the stripped gas may appear as long jellyfish-like tails against its direction of motion in the medium. So, I love this visual. This is so gorgeous. So, it's a galaxy, and it's literally like falling apart because of the pressure of the surrounding environment. It's so cool. I will have to do more research on dark matter. Yes, dark matter is very cool. I think a really cool starting point is the bullet cluster. It is two galaxy clusters colliding with each other, and it was the first indirect evidence of dark matter in astrophysics. Actually, let me see if I can pull up a quick image. It kind of looks similar to this article that we're looking at, but very different forms of matter. Ooh, my Wi-Fi is lagging. Oh, this is actually a link for an Astrobite that we read on a previous stream. Basically what this is showing is that we have two galaxy clusters that are colliding. And if I recall correctly, this contour is the matter distribution, so that's by measuring the gravity. And this colorful region is the baryonic matter, or the particles that we can see, so this is the light of the object. And the reason why the distribution of the matter as a whole and the matter that we can see is different is because of dark matter. And what happens is that the dark matter just moves through each other as a result of this galaxy cluster collision, whereas the matter heats up and is affected by the collision itself. So this bullet cluster was our first indirect evidence of dark matter. So I really recommend it, and it looks like there's a great Astrobites on it. So I'll send that in the chat if you want to read more. This was discovered quite a while ago. All right. But yes, we are reading about something a little bit different. We're reading about jellyfish galaxies. Oh no, not jellyfish galaxies. Jellyfish galaxies? No, ram pressure stripping that look like jellyfish-like tails. Jellyfish galaxies are are a similar process though. Jellyfish galaxies are what happens when a galaxy undergoes the pressure and it kind of falls apart like this as well. So this galaxy is moving through some high pressure environment and is being stripped off in this tail here, which is super cool. So yes, the background image shows the NGC 2300 group with the NGC 2300, the central elliptical galaxy, and the subject of our astrobite NGC 2276. We can see that the leading edge of the galaxy seems more compactified. The arrow shows a direction of motion in the sky, with illustrated green dashes indicating where the stripped gas is. The inset shows a figure adapted from the original figure showing the 100 kiloparsec long tail. That is insane. Like, that is literally gas just, like, trailing after the galaxy. Parsec is a really long distance. It's 3.26 light years. So this tail is ginormous. The spiral galaxy NGC 2276 is part of the same group as the elliptical galaxy NGC 2300. Ram pressure stripping of NGC 2276 has been studied in the past with X-ray observations, and has also been noted that one edge of the galaxy shows an increased rate of star formation. That makes sense because the one edge of the galaxy is being compactified, and when gas is compressed, it forms stars. The external pressure from the medium can compress gas and trigger star formation of the galaxy. Yeah, that's what I just said. And since it is the galaxy's leading edge interacting with the medium shows increased star formation, scientists think that the ram pressure must be being applied. The big discovery in this paper is that the resultant tail of gas, when observed using radio telescopes, seems to be 10 times larger, about 100 kiloparsecs. This study observes NGC 2276 using two different radio telescopes, LOFAR, based in Europe, and UGMRT, based in India, both of which specialize in low-frequency radio observation. The observation was carried out in multiple frequency bands. A frequency band is a range of the electromagnetic spectrum being observed. 7 bands from 54 MHz to 1230 MHz were used in their observation. Cool. As the gas from the galactic disk is removed via ram stripping, it is ionized and slowly diffuses away into the IgM. The process of ionization also releases electrons, which lose energy with time. The authors slice the image of the tail into small bins, and calculate how much energy electrons in each bin have lost, and with it estimate how far they've traveled along the tail and how much time it took for them. With this, they are able to figure out how long ago which part of the tail was stripped. It is an ingenious way to use the tail as a clock. That is so cool. That is so cool. they can measure the energy loss in different parts of the tail to determine how long ago the tail was stripped away. And they call this model the synchrotron aging model. We know how long the tail is, we know how fast the electrons travel down the tail and how much energy they lose. Putting it all together lets the authors calculate a velocity of 870 kilometers per second for the tail and skyplane. That is super creative. I love that. Orbital dynamics of a galaxy far, far away. For objects within the Milky Way or in our immediate neighborhood, we have been able to use parallaxes and proper motions to very accurately estimate the 3D velocities of objects with revolutionary observatories such as Gaia. These become harder and harder to measure the further away an object is, and with its current observational capabilities, they do not work beyond the local group. This essentially means for slowly evolving systems, like galaxies which are outside the local group, say for example in a cluster or group like the NGC 2300 group, obtaining 3D velocities ends up being very challenging. 3D velocities are crucial in characterizing dynamical interactions of galaxies. The authors use the 870 km per second velocity for the tail on the skyplane to estimate the 3D orbital velocity of the galaxy. Apart from its motion with respect to the center of the group, the whole group also has its own motion with respect to the observer. The astronomers assume that the central elliptical galaxy to be the rest frame for the group. It has a radial velocity of about 420 km per second. Using this, they calculate the 3D velocity to be 968 km per second. Thus, using the longest ram pressure tail discovered till the publication of this paper, the authors of this article are able to estimate the 3D velocity of a faraway galaxy. Extending this methodology to multiple galaxies in a group and cluster can help us get deeper insights into group cluster dynamics and maybe even use them as a tool for estimating their masses in the future. This is super cool. I love when scientists can get creative with their methodologies, and in this case where they were using the energy loss of electrons in the tail as a clock, super sick. Thank you to Neil Kola at the Paris Observatory, who I guess studies radio observation. Super cool. Yeah, this was a shorter article as well. Yeah, this is super neat, guys. Whew. Hello, Parafergon. Hello, you came at the perfect time though. You may be late, but it's okay. You came at the perfect time. We just finished our third article, and I'm actually curious. Maybe we should do a vote. Do you guys want to read on... I'll do a poll on YouTube. Article on how spiral galaxies form, or play self-descending singularity? Because we've done a lot of science today. Please vote on what you'd prefer. And for those of you on the Twitch side, YouTube is my primary platform, and you can go there and see if you'd like to vote. Vote on what you'd prefer. I'll give it a few minutes. Yeah, my rashes are starting to get itchy again, which is not good. I had to visit the pharmacy and I got this this urea-based lotion, which apparently is helpful for eczema. Both? I mean, if we hurry, maybe. Let me see how long this article is. Wait, this... Actually, it's not that long. Guys, do you want to do both? We can be a little late to Fi stream. We can be a little late to Fi stream. Because it is looking like roughly 50-50 on the poll. Okay, well, there is both. Okay, there is no time to waste. Zelda Singularity is a idle game. I previously played it earlier on my channel. But I wanted to give a quick update because I was playing it a little bit, but I haven't opened it in a few days. We are rowdy. Okay, guys. You know what? Second to last stream, gotta make the most out of it, right? Okay, how do spiral galaxies form? Theories of spiral structure. Oh, this is the same author as the first article we read. So this is based off of an existing article, I guess. Let's see what this quote is. Much as the discovery of these strange forms may be calculated to excite our curiosity and to awake an intense desire to learn something of the laws which give order to these wonderful systems, as yet I think we have no fair ground even for plausible conjecture. That is super philosophical. I love that. For decades, astronomers have been fascinated by the striking beauty of spiral galaxies and the mysteries of how their intricate structures form and persist. Although spiral galaxies rotate, their spiral arms are not stable enough to simply spin with the rest of the galaxy, raising a long-standing question in astronomy. How do these galaxies maintain their distinctive patterns over billions of years? This is a question that I've also been asked quite a few times on my channel, so that's why I wanted to read this. Understanding the formation and evolution of spiral galaxies is also essential to our broader picture of galaxy evolution. In the traditional Hubble sequence, spiral galaxies, rich in gas and young stars, were thought to gradually evolve into elliptical galaxies, which are dominated by older stellar populations. While this view has been challenged, spiral galaxies remain central to our understanding of the universe and the processes that shape it. So this is the Whirlpool Galaxy. Yeah, so back in the ye olden days, people would draw these galaxies. Like, Galileo also drew the moons. And I just wanted to say, I'm so glad that we don't live in that era now, because I'm a horrible artist. So I would not have been able to survive. But jokes aside, it is really impressive how much structure is being captured in its image compared to the telescope image. So theories of spiral structure, what a goat, yeah. Theories of spiral structure by Aller Toomer from 1977 highlights this ongoing mystery, so it's quite old, but it reads as both a historical review and a reflection on the many ways that astronomers have attempted to explain the origins of spiral galaxies. It remarks that the problem continues to taunt theorists, and that the more they manage to unravel it, the more obstinate? What in the world does that mean? Obstinate? Refusing to change your mind. So it's like stubborn. The more stubborn or obstinate seems the remaining dynamic. I learned a new word today. I think that despite decades of progress, no single theory could fully capture spiral structure. Spiral patterns are observed in roughly 60% of galaxies. Nevertheless, the central question remained unresolved. Why do spiral galaxies develop and maintain these structures in the first place? Old age scientists had either to be artists or hire artists to do illustrations and diagrams. Do you think they got commissions? I think they must have. They must have been able to get commissions. You think they went on VGen and they were like, looking for artists? Or do you think people were requesting for commissions on Discord? I guess not back then, but kind of funny to think about what it would be like if it was happening today. Early ideas explaining spiral structure. Bertil Lindblad was one of the first astronomers to develop a dynamical theory of spiral structure, and his ideas laid the foundation for many of the models astronomers use today. In his circulation theory, the spiral arms were thought of as patterns that rotate together through the galaxy at a constant speed, much like the hands of a clock. Later work expanded on these ideas by introducing the concept of kinematic waves. Instead of treating the spiral arms as fixed structures, this model described them as patterns that emerge because individual stars and gas clouds follow their own orbits, naturally spreading out or clustering together as they respond to the vibrations of spiral arms. The breakthrough came with the work of C.C. Lin and Frank Hsu, who proposed what is now known as the spiral density wave theory. Their key insight was that spiral arms are not made of the same stars and gas forever. Instead, they are regions where matter is temporarily more concentrated, much like a traffic jam on a highway. The traffic jam moves along the road even though the individual cars continuously enter and leave it. In the same way, stars and gas pass through spiral arms while the spiral pattern itself persists. Yeah, so I guess the answer is a lot of people's questions about what are spiral arms. They're basically like mini traffic jams. So they provide this figure of the wave equation to look at different spiral structures, looking at different tumor parameters, which are Q, labeled here. Comms Open must have owned telescope and be really good at describing what you see. Lamau. Yes. To describe this idea mathematically, Lin and Hsu developed a dispersion relation in Figure 2, which relates the wavelength and frequency of spiral density waves and determines how these wave patterns travel through a rotating galactic disk. Although this equation was a major advance, it took years of refinement to match observations. Vtuber later introduced the Q parameter, which measures the stability of a galactic disk against gravitational collapse. Subsequent work refined the theory by improving predictions for precession of stellar orbits, and refined the wave's pattern speed and the location of the co-rotation radius, the distance from the galactic center where the spiral pattern rotates at the same speed as stars. It's super cool that, like, we are able to look at these old articles and see how they've sort of evolved in the scientific community over time. In this case, how they were able to sort of evolve our understanding of galactic structure from this initial discovery here. One of the most important consequences of the Lin-Shu theory is that stars can slowly exchange angular momentum with a spiral density wave. Near the co-rotation radius, this interaction allows stars to gradually move inward or outward within the galaxy over billions of years. As a result, the spiral arms can survive for long periods, even though the individual stars that make them up are constantly changing. Many astronomers now think that density waves alone are not the whole story, and that additional processes may continually strengthen or regenerate spiral patterns. One clue comes from the observations of spiral galaxies themselves. Spiral arms contain a lot of H2 regions, clouds of glowing ionized hydrogen that mark the birthplaces of young stars. As gas flows into a spiral arm, it is compressed by the density wave, creating shock fronts that can trigger new episodes of star formation. Yeah, as I mentioned before, for stars to form, you need to have enough gas, but also good gas, as in gas with low enough temperature and high enough pressure to form stars. The result is a chain of bright young star clusters strung along the spiral arm, which Vtuber poetically described as strings of pearls. I just wanted to give this guy a shout out. This Vtuber guy is super poetic in his writing. I feel like research papers have evolved to be a little bit more objective now, but in this instance, he also had this, I guess that was another guy up top here with a very poetic quote. But String of Pearls is a gorgeous name. Other large-scale processes may also contribute. The differential rotation of a galaxy naturally shears gas and stars into elongated structures, much like cream stretched into swirling patterns when stirred into a cup of coffee. Many spiral galaxies also contain a central bar, which suggests that the bars may help drive spiral structure by redistributing stars and gas throughout the galactic disk. So I guess since then, we've really come to understand how different parts of the galaxy structure or rotation can affect how stars are formed or distributed. Luminous froth goes hard. Yes. Yes, indeed. Different mechanisms for maintaining spiral structures. Gas compressed within spiral density waves trigger star formation, while galactic shear and central bars may also help strengthen and sustain spiral arms over time. So they have bar formation here and shearing shown here. Last paragraph! Wait, I just had the most upsetting thought. This is the last paragraph of the Astrobites streams that I'm gonna be doing. This is the last Astrobite I'm reading on stream. Oh, this is so sad. Okay, wait, I'm so sorry, but it's just, very bittersweet moment, guys. Recent advances in numerical simulations have greatly improved our understanding of spiral galaxies. Unlike the early models of Lindblad and Vtuber, modern simulations include the effects of the galaxy's dark matter halo, which I talked about earlier in this stream, once considered only an unseen source of mass, and can incorporate the physics of star formation in gas clouds. These models show how shocks, shear, and gravity shape the formation and evolution of spiral arms. Overall, these simulations have suggested that spiral arms are dynamic features shaped by gravity, gas dynamics, and star formation, helping to explain the remarkable diversity of spiral galaxies observed today. Well, I think it's oddly poetic that, well, we started out with observations and then we ended on simulations. And given that simulations have been what I've been focusing on in my IRL work, it is kind of poetic that we're ending up on galaxy formation simulations. So, that's super great. You mean pre-hiatus, right? Yes. Yes. Please don't make me cry, Zia. Yeah, no tears will be shed today. That will be for next stream. Well, thank you to Shalini once again, who was also the author of the first article that we read. But yeah, this is great. I hope you learned something new. I love these reviews of historical articles too. They are super duper cool. I feel like it's super interesting to see. Sorry, I'm gonna just get Steam set up real quick. It's always super interesting to see like how the scientific field has really evolved. Like simulations themselves have been really a recent development, thanks to our scientific computing power. All right, cell to singular. Update queued. Update queued. Okay, wait. I just gotta update it real quick. Alright, one last cell to singularity once my update installs. So I have been playing cell to singularity since our last stream, but I haven't checked it in the past few days because I've been kind of busy. But oh, sorry, I'm jumping in the streams because I want to set things up. Oh my god, my computer is really being loud. Oh, oops. Cell to singularity. Infinity Pass expired. Okay. Wow. Okay, so I just wanted to show you guys my progress. Okay, hold up. I got to move myself around. I'm gonna shrink myself a little bit. Should I just be like this? I'm like a floating head. I'm like a floating head. Is the music too loud? Oh my god, it does. It looks a little loud. Okay, wait, I'll move myself back. Maybe I'll make myself bigger again. Maybe I'll be like this. Actually, I'll move myself up again. Sorry, I'm just moving stuff around. I just wanted to get this out of the way before the last stream, but thank you for the past 2 years. Even if you've been active, even if I've only been active for these last 2 streams. Well, I'm so thankful for all the Orbeez. Whether you've been with me from day 1, or whether you've been, you know, just newly finding my channel, you guys are amazing all the same. And really, I would not be doing this without you guys. So thank you for constantly inspiring me, for constantly, you know, teaching me so many exciting things. Okay, we're gonna double that. Yippee! Alright, let's claim. Alright, let me show you guys the progress. So, I've reset this a few times now, actually. Oh, let's just, like, unlock everything. Yeah, last time I had just gotten to 8, and now we have, like, a gajillion 8s. So, yeah. Another thing is that I unlocked this, like, dinosaur world. The dinosaur world is kind of freaky, so you actually have to wait for each of the like characters to like charge up per se, and you basically have to unlock the milestones on the side, like what I'm doing right now. Like on here, so it says collect 3 Stegosauruses, so we can do that really quickly, and they give you geodes which you can unlock, and once you unlock enough geodes, you basically undergo this like meteor event. So we can quickly collect, how many do we need? We need like 59 Ankylosauruses. So we got this one. Woohoo! And then we need like a gajillion Ornithia. So like that. And you can collect these mutagens, and now you can upgrade the characters. So if you click these cards here, you can upgrade the characters. I don't know why I'm explaining this, because I realized that some of you guys watching this might already know how to play, but I've been a total noob when it comes to this game, and I've been learning everything one by one, so please bear with me. Spooky summer ending soon. Okay, yes. Oh, I did play, so they have these like limited events. And so I've also been Holy smokes, 13? Wow, I'm rich. What's really great about this is that it really is so low commitment. I'm not very good at video games. I've talked about this when I actually played this on stream. And I feel like I love games that are like very idle, like this one. I used to play Cookie Clicker a lot for that reason too, because the strat would be like, you know, in between work, like I check my idle game and see how it's progressing. And now, like after work, after I'm using my real simulations, I can now go to my simulations of dinosaurs and, in this case, a meteor event, which I will be inducing at the moment. It's great. 403 creatures. Crocodiles added to the main simulation. It's so addictive. I don't know how far people have made in this game, but some people were saying that you really need like several hours to get every feature in this game. So I will unlock some of these new characters. I love how every time the simulation resets, it's very satisfying to get it like back to where it was originally. Also, the music is so banger. This has been my favorite thing to do, guys. See, okay, this is like a day in the life of like what I'm doing. Okay, photograph ornithia. Okay, which one is that one? I don't think it's this one. I think it's this one? Yes. I just like collect the geodes and I rinse and repeat. Hello, Cerno. What is the name of that music? I think it's like just classical music. I think it's like Beethoven or something like that. Because when I was playing this, I did not update. I did not get a copyright strike after playing this game on stream. Because classical music apparently does not have copyright strikes, or certain classical music at least. Anywho, oh yeah, I played this a little bit too. And it shows you like what song it was. Like YouTube is able to detect what song it was. So I gotta collect this and Stegosaurus as it appears. Wait, let me just do 10x. I also didn't realize this feature when I played on stream last time, guys. Like, I was just straight up like clicking things multiple times. There's also 100x, max, and round. Stegosaurus, Triceratops. Woohoo! I can probably upgrade these guys, yeah. Oh. Isn't this the one soundtrack from the Backrooms movie? Bolero? Maybe it is. Maybe someone can try Shazamming it. I was going to ask. Okay, for those of you who watched the Backrooms movie, how is it? Because I would love to see it. I also have not seen Odyssey, but I'm going to go to an IMAX theater. Whoa. I'm going to go to an IMAX theater when I'm back in the United States, so I'll be able to see it. But sorry, back on task. Backrooms movie, thoughts, opinions. Is it worth watching? Is it still in theaters? I don't know if it's still in theaters, actually. I may have missed the window. Yeah, guys, look at my map. For those of you who were here last stream, like, I was such a noob. And now things are a lot better. I gotta be able to collect human, though. And we are very far out from that. So, another thing is that you can go here and, like, upgrade. Reboot the simulation to collect your converted currency. So if I get that, I won't really be able to unlock anything. Yeah. It's from the Exit 8 horror movie. Oh, I heard that one was good too. Thoughts on that? My friend recently watched the Blair Witch Project, but I feel like that is too scary for me. It's creepy, like in a something feels off about this place. Backroom rules, okay. Because I watched Obsession and I loved it. And people were saying that like Obsession and Backrooms were like happening at the same time, and it was like kind of like Barbie and Oppenheimer again. But I didn't watch Backrooms. I don't know if it'll be out on like Netflix or another streaming platform. The first time I saw it, I thought there was gonna be a jump scare around every corner. Guys, I'm not very good with scary movies though. I thought the Backrooms movie was by Kane Pixels. Upper Bounds. I also wanted to give a shout out because what's really interesting is that this team continuously has these like really cool additional challenges. Like for this one, you can like explore the atmosphere. We can check that out really quickly. And then in the meantime, let me check Phi's stream. Is Phi live? Oh yeah, Phi's getting started. Alright. Okay, we can unlock one more ape. Boop. And then we can check out this special event. So, from what I'm hearing, I will have to try watching it. Look up at the sky. It is right there, but out of reach. What forces shape the world above? Explore atmosphere. Hopefully this is more space themed. Some of the bonus worlds here have been not very space themed, I think. Wait, tap to earn elevation? Oh, that's cool. So you can go to like the troposphere. Okay, troposphere unlocked. Knowledge unlocked. That's so cool, guys. As you can see, I'm very hooked on this game. Okay, we need to get air. We need to unlock air. Okay, we'll unlock another troposphere to go a little bit faster, and then we can unlock air. Thank you to whoever told me about this game. This is amazing. I love this. Oh my god, my finger is getting sore. It's so sore, guys. Air unlocked. Okay. Whoa. Okay. One lodgit. Okay. Collect sunlight. How am I supposed to do that? Oh, you have to unlock. Okay, cool. You have to unlock oxygen and nitrogen. The scientist in me loves this game so much. Woohoo! Yippee! This is actually cool. This is a cool special event. Some of the special events have been very strange. Like the previous one was on like cryptids or something like that. But this one's actually kind of adorable. I like this one. So yeah, this is basically what I've been interested in recently. The pipeline of reading 4 science bites into unlocking the tropozone is crazy. Well, we were learning about how galaxies die, and now we are like, ah yes, nitrogen and oxygen. But hey, it's all science nonetheless, right? Which makes it cool. I want to unlock nitrogen. Please, please! And then we'll wrap up and then we'll raid into Phi's. I have it enabled on YouTube, so we'll just raid into Phi on YouTube. If anyone has games that run on Mac, please let me know. I also, one of the previous viewers, AA1A, They actually gifted me Balatro on Steam, which was really kind. I will also be playing that game in immense quantities, over my hiatus, so I will keep you guys updated. But I've been, the game that I've been playing the most for the longest time has been, Cult of the Lamb, actually. But there haven't been any new updates in quite a bit. Oh my god, trigger this boost. Maybe I will use this. Wow, we're zooming. Okay, we'll unlock Oxygen and then we'll raid into Stream. What better way to, you know, bring us back down to Earth, after, you know, talking about Galaxies, right? It is very cozy, and I think the music contributes to it too. Even these special labels, these special ones have their own music. Okay, so we can quickly check on our other simulations. Guys, this is so close to my in-real-life work. I love working with simulations. Simulations are so cool. Okay, collect. Okay, we can unlock a plesiosaur. Plesiosaur! That is so cool! Oh my god. That is so sick. Wow. It's literally a Loch Ness monster. Okay, we need to collect 40 Stegosauruses. And then Ankylosaurus. And then, sorry, I'm not talking much. This shows you how looped in I am with this game. Like, look at how developed this tree is. We can unlock the Brain of Ape, I think. Or what else have we not unlocked? Brain of Ape. Like, look at this. While I'm on hiatus, I will continue to update you guys on how far I make in this game, because it has been so much fun to play. Alright, we're gonna check on our atmosphere, and then we will raidify. Oh my god! Please! It barely collected any while we were gone. Okay, we're almost there, we're almost there. We'll get to 7,000 soon enough. While we wait, just wanted to announce once again, my last stream will be on Monday, August 10th at 8 p.m. Central European Summertime, so that is 20 minutes from now, for those of you in different time zones. I will miss you guys so much, but no need to cry right now. We can cry at the last stream. I'll be answering questions from you guys. And, speaking of, if you haven't submitted a question and you'd like to, I am accepting questions still here. So it is your last opportunity to submit questions. Alright. And if there is anything else you'd want me to share during the last stream, I'm just gonna highlight some art and my favorite moments from this past year, and really celebrate this last moment together. Okay, and we've unlocked Oxygen, so yeah, so this is a little bit of a showcase as to how addicted I am in this game. Shoot. Let me just hide that. Let me hide that. Oh, that was close. I realized that it shows your real email address in the thing, but I didn't show it, fortunately. Here, let me exit the game, and then... Glad to be Black Hole member for one whole stream. I will definitely submit a question. Well, if you are a Black Hole member, please keep in mind that I will continue to send my updates, my Zmail, my subscription updates, even during hiatus, which will showcase some of my travels, my favorite papers, etc. So, but of course, no pressure to continue while I'm on break. Hello, Tylenol. We are just about to raid into Phi's stream. So it should automatically redirect, if I recall correctly. Yes. So if you are on the Twitch side, please go to the YouTube stream. And actually, let me actually link the specific stream link itself, because then we will raid into Phi's stream. So Phi is another collaborator of mine. He's part of Vtuber, which is this group of scientific communicators that I'm part of. And he just hit 100,000 subscribers on YouTube, which is super exciting. All right, guys, I will see you guys on Monday for the last stream. But thank you guys so much for making the Astrobite stream as amazing, as incredible as it can be. I miss you guys already. But I will see you guys on Monday. So get ready to raid. Get ready to raid. All right. I will see you guys in the next one. Bye-bye. Bye-bye. Bye. 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 Miss you guys already. All right. Get ready to, oh, wait. I just copy and paste this message real quick. And we will raid. Thank you guys so much. See you guys soon. Okay, bye. Bye.